Hi guys. So today we are going to look at cycle detection in a directed graph. And the technique that we're going to use for this is called graph coloring. So as you can see clearly in the first graph, there's two cycles. So you can go from node 2 to 3, and then 4, 5, and then you're coming back to 2. Similarly, if you go from 2 to 4, then 5, and then you're coming back to 2. So there's a cycle. In this graph, there are no cycles. So there's no way you can come back to the same node, right? So there are no cycles. So we're going to go through both of these examples to see how the coloring scheme works. And this, we are actually going to use DFS for this. So first of all, to understand what the graph coloring scheme really is. So it is assumed that when you're starting off, none of the nodes are visited. So all of the nodes are in the beginning going to be white. All nodes are white in the beginning. When you start visiting them, they become gray. And when you're done processing all the neighbors that belong to a particular node, they become black. So how does this help us in detecting a cycle? So while traversing, when you go from a white node to, let's say, a gray node, and you follow that cycle, you go to all its neighbors. If you come back to a gray node, then there's a cycle. So if we are, while visiting, if we visit a gray node, there's a cycle. But while visiting, if you visit a black node, you don't traverse further anymore because that node has been already processed. So you say that there's no cycle in that case. And of course, if none of these cases happen, if you're just visiting a white node, then also you haven't detected a cycle yet. So a white node basically just represents that a particular node has not even been visited yet. You haven't even visited it yet. A gray node means that you are visiting it currently. Probably you're on its children at this point. So from 1, you go to 2, and it's got, by children, I mean neighbors. So from 1, you go to 2, and it's got 2 connections, right? 3 and 4. So let's say while traversing from, and because we're doing DFS, we'll go from 1 to 2, and then first we chose, let's say, 3 instead of choosing 4. So you go to 3, and then from 3 you're going to 4. So if you process it that way, and while doing that, if you come back to the same node, then that's a gray one at this point, because we weren't done exploring all the neighbors that 2 had, but we still came back to it. There's a cycle, but at that point, till the point you haven't traversed all the neighbors, it's a gray node. And when you're done traversing all its neighbors, that is when it becomes a black node. So actually, through example, we'll find out more about this. But let's first look at the graph representation of this, right? So we're going to use the adjacency list to represent the graph. So let's say 1 has neighbors. In this case, it has neighbors 2 and 3. So if 1 is processed, then you're free to process 2 and 3. 2 has neighbors 3 and 4. 4 has neighbors 5. 3 has neighbors 4. And 5 has neighbors 2. Let's do the same for this one also. So 1 has neighbors 2 and 3. 2 has neighbors 3, 4, and 5. 3 has neighbors 4. 4 has a neighbor 5. 5 has a neighbor 2. So this is the graph representation. We chose the adjacency list. Now we want to use a format to represent the coloring scheme also. How do you represent if it's a black node, if it's a gray node, if it's a white node? So what we're going to do for this case is that we're going to use a hash map again. And the moment you visit a node, you're going to add an entry for it. And the value for that key, so the key will be the node, and the value for it will be a Boolean value, which will be false to begin with. So that pair actually would represent that the node is gray. So in your map, if you have node 1 and its value at this point is false, then that means that it's a gray node. But if when you are done processing all its neighbors, you update this value to true, and that will represent that this has become a black node. So that is how you identify a gray node and a black node. And if an entry is not even present, then that node actually is a white node. So we will update this map that we're going to create for storing the coloring scheme as we go and traverse through the DFS. So let's start creating what this map will look like, right? So first we're going to start off with 1. So you go to 1, so you add an entry for 1 and you say false. This means that at this point it is being visited and its value at this point is actually false. So that just means that it's being visited, but it's gray, as in it's you haven't yet come back from traversing 2 and 3. So at this point it's just gray. So let's mark it as a node that is being visited at this moment. And then we go back. At this point we're going to go to, from 1 we're going to the first neighbor, which is 2. So we will add an entry for 2, which will also be false. So both of these nodes at this point are just gray. Then from 2 you're going to go to 3. You add an entry for it, it's false, so it's gray. From 3 you go to 4. We're doing a DFS, right? So from 3 you go to 4, and so it's the node 4 also becomes a gray one. From 4 you go to 5 and it becomes a gray one. So we aren't done processing any of these nodes yet, but at this point we have come to 2. They're all gray. So 2 is gray, 5 is gray, 4 is gray, and 3 is also gray. And this is what the map is also representing. All of the nodes are gray. Now from 5 you're going to go to 2, right? So when you go to 2, you see that it's actually a gray node, right? We see that it's actually a gray node because it hasn't been processed yet. This color basically indicates that it's a gray node. So since it's gray, you haven't yet processed it, there is a cycle. So from 5 we try to go to 2, we check the value and it's false, it's a gray node. We say that we detected a cycle. So that is how you detect a cycle. Let's run an example for a graph that does not have a cycle in it. Let's build the coloring map for it. So you start off with 1, you add false to it, means it's a gray node. You go to 2, you make it false, mark it as gray. You go to 3, mark it as false. We're doing a DFS, so we're going from 1 to 2, from 2 to 3. From 3 we're going to go to 4. So we go to 4, mark it as false, it's a gray one. From 4 we go to 5. This wouldn't have any value. 5 does not have any neighbors, so it wouldn't have any value. It would be an empty list, and we mark it as false. This is the graph. Now we start coming back because 5 does not have any neighbors. So we start coming back. So we are going to go back to 4, back to where the call came from. So while doing that, we're going to update this value to true. At this point, it means that this actually has become a black node. So we're done traversing 5. There are no neighbors. From 4, there are no neighbors. So you update this value to true as well. And let me update. So when you're traversing, right, when you're done processing them, 5 has been processed completely, it's a black node. 4 has been processed completely, it's a black node. You will go back to 3. So 3 does not have any other neighbors, so it is also a black node. It will become a black node when you're done traversing through it. So let me update the value in the map as well to indicate that it has become a black node. So now the value for 3 will also be true and it has become a black node. Now we are at 2. We go to 3. We go to 3. From 2, we'll go to 3. And we check that it's a black node. So we don't return false, true, because we haven't detected a cycle. The node that we visited, again, the value for it is present in the map, but the value actually is true. So it's a black node. So there is no cycle. Then we go to 4. 4 is also a black node. So there is no cycle. But we don't traverse these nodes again. So this basically acts as a visited matrix as well, because since we are done traversing 3, we're not going to 4 again and from 4 to 5 again. We're not doing that. But we are not saying that we are detecting a cycle, because the nodes that are being revisited are actually black nodes. Then 4 doesn't work out. We don't traverse 4. We go to 5. 5 is also a black node. We see that it's a black node. All of these were processed. So at this point, we figure out that there's nothing else left to explore, right? So we're going to mark that one as a black node as well. And we're going to say that this has been processed also. And I just have to update its value to indicate that this has also become a black node. Now we're done. From 1, we go to 2. 2 is a black node. So we don't return false, but we don't traverse it. And then we go to 3. 3 is also a black node. So we don't traverse it, but we don't return true, because we haven't detected a cycle. We actually hit a black node. And so when we're done with that, we're done with everything on the graph. We've traversed everything on the graph, right? So we're just going to mark it as processed as well. And we're out. So every node has been processed and we did not detect any cycle. So this is how you can use DFS and the coloring scheme to detect if there's a cycle in a directed graph or not. Now let's try to code it out. The code is pretty simple for this one. There's not much to do, but this is just basically something that you should know how to do, because a lot of questions usually boil down to just detecting a cycle in the graph. So I have created a template for this. I will be uploading this on GitHub and adding a link in the description. So you can just use the code if you want to. The second example, the second graph that I have has the cycle, because I've used the same example, that the one that I've shown in the pictures. The second graph is this one, in which you have a edge from 5 to 2. So this is that graph. This one, you have an edge from key 5 to 2, the node 5 to 2. And this one does not have any cycles. So you don't have any edges from 5, as in the example. You have no edges in 5. So in this case, this one should be returning true, right? Because there is a cycle in this case. And this one should be returning a false, because there is no cycle. So let's just start writing the code. Since I'm passing the graph in the method, I want to set my graph over here. So this dot graph is equal to the graph that we're sending it back, sending it in the method. The visited map that I have over here is going to store the coloring scheme. As I said, it's going to have the node and the Boolean value to indicate if it's a black node, if it's a gray node, which kind of node it is. Now we're going to want to start a DFS from every node. We don't want to start a DFS from just one node, because in this example, there was a way for us to traverse from one node to another, but they could very well be not connected as well. So if all these edges were not present, if they were not present, then this graph would be disconnected, right? So we want to do a DFS from every node, and that's what we're going to do. So we're going to do the DFS, and to the DFS, we're going to send, so let's just take the key set, and if the DFS, I will return a value, I will return true back if I detected a cycle. So if we detected a cycle while traversing, then I want to return true from here as well. And I get the node. If I detected a cycle, I will just return true. And if I did not detect a cycle, I will return false. After processing all the nodes, after going through all the key sets present in the graph, basically all the nodes, I will return false if I did not detect a cycle. Now, in the DFS, if the visited, the coloring scheme where we are storing the hash map that where we are storing the coloring scheme, if it contains the key, the node, that means it's present. So either at this point, the node is either gray or it's black. If it's gray, we want to return true. But if it's black, we want to return false. But we don't want to continue doing the DFS, rest of the DFS in any of these cases, right? But it just depends what we return back. Do we want to return true or do we want to return false? We will just return visited dot get node. So we get the value from it and we return false or we return true from here. So if it's a black node, then we're going to return false because there is no cycle. If it's a gray node, then we're going to return true. Otherwise, if it's coming down, that means at this point, it's a white node. It's a white node. And we want to convert it to gray. So what does that really mean? What do we have to do for that? We just have to put a value in the graph for the node, and initially its value is going to be false, right? It hasn't been processed. So that is it. That's how you mark a node as gray. Now we're going to go to, let's go to the neighbors. So we are going to start the traversal. So we're going to get the neighbor from graph.get the node, right? Oh, we already have the neighbors. We can just use that. Just the neighbors. Now we're going to do a DFS. So, and here also, we just want to return true in case there is a cycle. Why move on with the DFS? I have to get the node and its neighbors, and I want to return true from here if the DFS itself returned true. Now after coming out, at this point you have traversed all the neighbors. You've explored all the neighbors for this particular node. So you want to mark it as black, right? What does that mean? We just update the value to true. We're done exploring. So we mark it as black. That is it. And if at this point we haven't detected any cycles, we are just returning a false. That is it. It's pretty straightforward. The code is pretty straightforward. Let's try to run it and see. So this is the result. The first one does not have any cycles and the second one does. I hope that helped you guys. Have a good day.